Okay, right, done. So in this video, we are discussing about the voltage regulation using the Zener diode. This is Zener diode application. Already we discussed this one is a Zener diode. Zener diode can act as a regulator, voltage regulator or power supply regulator. Regulation means to holding the parameter constantly. Wherever we go, output voltage we are holding, constant output voltage we are holding. Here, two types of the regulations are there. One is line regulation, second one is load regulation. In line regulation, we are keeping the constant load. Load is we are keeping constant and we are changing the voltage, input signal we are changing. Output voltage constant is coming or not, we are checking. This is type of regulation, we call it as a line regulation. While changing the input voltage, we are observing the output parameter is constant or not. Clear? What is load regulation? Input voltage we are keeping constant. Suppose 6 or 5 volts we have to keep constant. Now changing the load changing. With respect to load, we are observing the output voltage. Such type of regulation we call it as a load regulation. Clear? Now we will see what is our aim to study the regulation. What regulation? Voltage regulation. Voltage is our ultimate goal is voltage is we have to maintain constantly. So that is the by using a Zener diode. In our TV there is a stabilizer is there, no? We are getting the constant voltage purpose, we are keeping the stabilizer. Same way, by using the Zener diode, we have to stabilize the voltage through this experiment. Clear? Now what are the operators are there? First Zener diode, already we know the Zener diode, this one is a Zener diode. Next resistor, here 100 ohms resistors, we are taking the 100 ohms resistor, voltmeter, load resistance box, power supply we need. These are the operator. This one is a power supply, this is the analog circuit trainer. In this analog circuit trainer, AC voltmeter, DC voltmeter, DC ammeter and power supply. Two types of power supplies are there, potentiometer, DC voltages. So switch also we able to observe and AC voltages also we have to observe from this trainer, analog circuit trainer, clear? Now what are the formula once you have to see? Here in this diagram, by applying the Kirchhoff current law, suppose you have to take, this is the current I is coming from this power supply, right? This I current is divided into Zener diode, that is IZ, right? This is the milliammeter, how much current is coming, you able to see in this. This is why we have to take it is your reverse bias. Always Zener diode you apply as a reverse bias. Reverse bias means battery positive terminal you have to connect it into the negative, battery negative terminal you have to connect it into the Zener diode positive terminal. Such type of diode we call it as a Zener diode reverse bias. Clear? Some more current also going, that current is IL current. Clear? From the diagram, I is equal to IZ plus IL. By using the Kirchhoff current law, we have to write this formula. Similarly, you able to take here, this is a loop, one loop you have to consider. So this voltage is load voltage VL. This whenever this Zener diode voltage is load voltage is when equal, this current is I into R. This complete loop you have to take, VL is equal to Vs minus I into R. This formula we are getting by using the Kirchhoff voltage law. Which law it is? It is a Kirchhoff voltage law. While you have to take here Vz is equal to 0 volts, you have to consider that Vz is equivalent to the VL. What is VL? VL is equal to IL into RL. So these load voltage, this voltage we call it as a load voltage, right? Now we have to apply here line regulation and load regulation is there. Circuit diagram is the same. One time we are keeping the constant load, that is 15,000 we have to keep ohms, that is 1.5 k ohms you have to keep the constant voltage. We are changing the input voltage. First, you have to see the circuit diagram. How we have to connect the circuit diagram once you have to see. This is the power supply positive. Power supply positive to 100 ohms resistance one end you have to give. 100 ohms resistance another end you are going to give the milliammeter positive. Milliammeter negative to Zener diode negative. Zener diode positive you are going to give the ground. So then, so power supply negative is the ground, and next, so this load resistance one end you have to give to the ground, load resistance another end you have to give to the where you have to give the load resistance another end you have to give to the wherever the resistance another end is there you have to give, right? So now you able to see this is the output voltage, this one is the output voltage. Now input voltage purpose I am keeping, this is the input voltage. Now this is the circuit diagram. From this circuit diagram, how we are going to take the observations once you have to see. Here you have to take, this is the 500 and this one is 1000. 500 plus 1000, 1500. So 1500 we are removing. How much we are removing? 1500 we are removing. That is 1.5 kilo ohms we are removing, right? So we are keeping the load resistance is fixed. Now I am applying the input. So how much input I am applying once you have to see. The input voltage you apply, first 1 volt you have to apply. Input voltage is 1 volt you have to apply. Clear? Now you see input voltage is 1 volt. Now you able to observe the output voltage. So what is the output voltage? Here in the resistance is there, no? Here you have to keep this output voltage also you are getting the 1. So current is equal to 0. Now you able to see here again you have to change the input voltage. So what is the input voltage? How much input voltage is there? That input voltage you are able to see. That input voltage you observe 2 volts you have to observe. 2 volts you have to observe, right? 2.1 to 2 volts you able to see, that is the 2 volts is there. This is the input voltage is 2 volts. Now you are able to see the output voltage, right? Output voltage here you have to keep this one. Here also you are getting the output voltage also 2 volts you are getting. Now you are able to see what is this input voltage 3 volts you have to observe, 3, 4 and so on you have to observe. Just I am applying the 6 volts I am applying. You have to see how much output voltage you able to get. You able to see output voltage for 6 you are getting the 6, and for 7 you able to take the output voltage. How much output voltage you are getting, that one also you able to see, right? So every time you are changing the input voltage and output voltage you have to change. Uh, Input voltage and output voltage you have to change. Clear? You observe the value and take the graph. So what is the graph? That graph you able to take. Clear? So this graph will come like this. While changing the input voltage and while observing the output voltage, gradually it is increasing, again stable it will come. So due to this graph, whenever we are changing the input voltage but output voltage is constant. So this type of regulation we call it as a line regulation. Now we are fixing the input voltage. We are fixing the input. Suppose you have to take input voltage is 6 volts you have to fix, right? For 6 volts I am fixing. Input voltage is 6 volts you have to fix. How much? 6 I am fixing. Input voltage is 6. Once you have to fix the input voltage, now you keep the output here, right? Output you have to keep. You can change this load you have to change. Suppose from this 20 ohms you able to change here. 20 ohms resistance you have to change. Now the current voltmeter is equal to 1.03 is there. Again you have to take the 40. So 20 plus 20, 40, 1.54 it is coming. 1.54. Again you have to change a 60. Now you keep the, based on your intelligent brain, you able to adjust 50 plus 10, 60. Now how much it is there? 2.03. 2.03. Again 80 you are able to 62.03. 80 you have to write. So 50 plus 30, 80. So now you are able to take 2.44, 2.44, 100. So now you keep this all, you have to keep tightly, you fix it. Tightly you have to fix. 100 you can remove. This is the 100. How much? 2.78 and so on. 2.78 and so on. You have to increase the load resistance versus and output voltage. You able to take the graph. So gradually it is increasing. Initially 1.03, 1.54, 2.05, 2.44, 2.76 and go on, it will come. After some time it will be stable, right? So therefore by using the load we are maintaining the voltage is constant. Such type of variety we call it as regulation, we call it as a load regulation. Clear? So hence through this graphs, input voltage versus output voltage, load resistance versus output voltage, we are climbing that, we are climbing the result. What is that result? While changing the input voltage we are getting a constant output, while keeping the load resistance is equal to 1500 ohms. Here also we are keeping the input voltage is equal to 6 volts. We are keeping the constant, maintaining the constant output voltage. By this graph we are assuming, we are telling it is successfully acts as a regulation. Which regulation it is? Voltage regulation, because voltage parameter is holding constantly. So by using the Zener diode. So this is the characteristics of a voltage regulation of line and load using the Zener diode. This is way we have to explain and we have to tell in your examination. So please share and subscribe our YouTube channel. Thank you.